Okay, so Unit 4 is all about polynomials, and basically a polynomial is something that has an exponent. We're going to start off with just focusing on quadratics. So remember that a quadratic is anything that has an x squared. When you have a quadratic in standard form, though, standard form is going to look like this. We're going to have parentheses with x minus h squared plus k. And then you have your a in the front. And we've talked about this already, where h and k is your vertex. So what we're going to have to do first is we're going to have to understand how to write an equation in standard form given the vertex and a point. Now, because you're given a vertex, the vertex has to get plugged into the equation where h is 4 and k is 1. So if we start off there, that gives us a very good starting point. Now, as we move on to the next step is to plug in the point. The point is going to be an x value and a y value, so x equals 2 and y equals 3 would be the next thing we plug in. Once you plug it in, you can simplify, starting in the parentheses. So if you work all that out, you end up with 4a minus 1. And the 4 comes from 2 take away 4, which is negative 2, and then you square it because you have to do the order of operations. Parentheses first, and then exponent. That's how you get the 4a. After that, you basically solve just like any normal equation. So you're going to have to plus 1 and plus 1. And so that gives you 4 equals 4a. And then you just divide by 4. So that means that a is equal to 1. Now the reason why we did all of that is because now we almost had the entire equation once we plugged in the h and the k. All we were missing was the h, or the a in front. So what we're going to do is we're going to take that equation over here, and we're going to now substitute in everything that we have. So it's going to be y equals, now you can put the 1 in front if you want, but it's not necessary. So it could look like this if you'd like it to. And then x minus 4, and then minus 1. And again, this 1 in front is not really necessary, so if you want to take it off, you can. But that's your final answer. Next question. It's the same type of question, except now it's in the form of a picture. They give you the same information as the last equation, though. So the vertex is going to be the starting point of this graph, which is right here. It's also kind of like the midpoint of the graph. So that means that this has to be the h and this has to be the k. So we're going to go ahead and plug that stuff in. And then if you notice, we also have a point. So if we plug in our point, remember that the point is x and then y. Once we get everything plugged in, we should be left with just the letter A. Once we have that letter A all by itself, and it's the only remaining letter, we can solve this. So 4 take away 3 is 1, and then 1 squared is still 1. So you end up with basically A equals 1, because it's 1A equals 1, and you don't have to divide by 1. So now we take this equation here, and we substitute in the 1 in front, which again, it's optional. And then that plus 0, you also don't have to write that one down. So I'm going to go ahead and take off the 1, and then I'm not going to write down the 0 at the end. You can if you want to, but if you ever see like a multiple choice test, like on the final, it'll never have the 0 at the end, and it'll never have the 1 in front. Okay, next equation. It says the vertex is at 2, 3. So remember, the vertex has to be h and k. So if we start there, we start off like that. Now at this point, we still have a lot of letters. We want to get it down to just one letter, so we want that a all by itself. So the next thing we're going to do, just like all the other equations, we're going to plug in x equals 0 and y equals 2. So then we're at this point. Now, every time you get to this point, it's always the same steps. You start in your parentheses, so 0 take away 2 is negative 2, and then you square negative 2. Negative 2 times negative 2 is positive 4, so this is going to be 4a, and then we drop down the plus 3, and then this is equal to 2. So now to try to get a by itself, I'm going to subtract 3 from both sides. So I have 4a is equal to minus 1, and then I have to divide by 4. Divide by 4. So that means a is equal to negative 1/4. So we know that's going to be a reflection and a compression. So we're going to go ahead and take this part right here. We're going to scoot it over, and we're going to plug in what we just found. So we found that a was equal to negative 1/4. So I stick a negative 1/4 in the front. So it's going to be x minus 2 and then plus 3. And that's our equation. Okay, the next part is kind of working backwards. We have to sketch the graph using the vertex and the intercepts. So to find the vertex, you just have to find your h and your k. Remember that h is located in here, and it's always going to be the opposite sign of this guy, and then it's your k right here. So the vertex, your vertex is going to be positive 3 and positive 4. So we can actually start this sketch immediately. So we're going to go 3 to the right, and then 4 up, 2, 3, 4. Now, because of our knowledge of parabolas and just graphs in general and how they work, we know that a is equal to positive 1. So we know that this graph has to go up. If it's going up, it's not going to have any x-intercepts. If it did have an x-intercept, we would have to just set the problem equal to 0 and then solve it. So I'll show you how to do that, and I'll show you what happens when you don't have an x-intercept. We're going to subtract 4 from both sides. So we have negative 4 equals x minus 3 squared. And if we want to get this x by itself, we would just have to square root the whole thing. Now here's the part that causes the graph not to cross the x-axis. If you go into your calculator and you put in shift square root, oops, not square, I don't want a square in there, and then negative 4. Oh, I deleted the whole thing. Hang on a second. Square root and negative 4. Your calculator is going to say non-real answer. So what we need to do is we need to go into the settings. So I hit shift setup and we go down here to see if this is going to work for me right here. So we go to complex mode and we want to change it to a plus bi. So what that is going to allow the calculator to do is it's going to allow it to fix the problem for us because we're not supposed to have negatives. So we end up with 2i. So the answer is going to be plus or minus. Now I'm doing this because if there was no negative there, that's going to show you where it's going to cross the x-axis. But because it has this I, that I right there is a red flag telling you that this thing is imaginary. So then the last step, because the square and the square root cancel each other, the last step would just be to add the 3 over. So I would add the 3 over to the front. So this would be 3 plus 2i, and then 3 minus 2i equals x. And because it has this I on it, you cannot graph something that has an I because our graph paper is set in the real number system. Real numbers only go on graph paper, basically, is what that means. So if you want to find, if you wanted to find the x-intercept, the x-intercepts are found by setting y equal to 0. And I'm going to highlight that. That's going to be important because not every question is going to have an I like this one did. And if you wanted to find the y-intercept, you just set x equal to 0 and solve. So this question is going to say y equals 0 minus 3 squared plus 4. 0 minus 3 is, what is that? Negative 3. And then if I square that, that's going to be positive 9. And you can do all that in the calculator, but that's going to tell you that the graph crosses the y-axis at 13. So we'd have to draw a lot right here. That's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you would have a dot here, and then because it's symmetric, if it's 3 away this way, it's going to be 3 away this way to get that other dot. And then this isn't perfect, but that's why we call it a sketch. Sketches are not perfect. And that's how you do that question. So with that, you should have enough information to complete today's assignment.